Hi everyone, it's Miss Owen here at BMS, and today I'm going to show you how to multiply polynomials. So our first example is a binomial times a binomial, and when you multiply two binomials together, we use what's called the FOIL method. So I'm going to go over the FOIL method, but I like to say that the FOIL method is just like the distributive property twice. So I know all of you know how to use the distributive property, so we are going to not only distribute the 7 to both of these, but we are going to distribute the n to both of them. So I'll explain distributing twice and the FOIL method. Okay, so let's start with distributing twice. Because we're taking a binomial times a binomial and they are both in parentheses, I am going to distribute not only the 7 but also the n. So we're going to distribute the n to the n plus 5. So n times n is n squared, and n times positive 5 is positive 5n. So then after you distribute the n, then you're going to go back and distribute the 7. So I like to show distributing the first term, the arrows on the top, distributing the second term, arrows on the bottom. So 7 times n is positive 7n. And 7 times 5 is positive 35. Then we combine like terms if possible. Usually these two middle terms you'll be able to combine. Sometimes you will see that they will cancel, and that's okay. So when I combine my positive 5n and positive 7n, that leaves me with positive 12n. So my answer is n squared plus 12n plus 35. So just think of FOIL as distributing twice, or multiplying two binomials as distributing twice. So let me quickly go over FOIL and what FOIL means. So FOIL means first, outer, inner, last. So first means that you're multiplying your first terms in each binomial, so n times n. Outer means you're multiplying the outside terms, or the terms that are on the outside, so n and 5. Inner means we're multiplying the inside terms, so 7 and n. And then last means that we're multiplying the last terms in each binomial, so the 7 and the 5 are the last terms. But I like to again say that it's easier to just think about it as distributing twice. Okay, so let's look at another example. So if I think about it as FOIL or distributing twice, it's the same thing. So I'm going to distribute this 5k to these two terms here. That's my first and that's my outer. 5k times 2k is 10k squared. 5k times negative 3 is negative 15k. Okay, now that I'm done distributing the 5k, I'm going to distribute my positive 2. So 2 times 2k and 2 times negative 3, which is my inner and my last. My inner and last. So 2 times 2k is positive 4k, and 2 times negative 3 is negative 6. Again, you should be able to combine these like terms here in the middle. So when we combine negative 15k and positive 4k, we'll be left with our answer. So we have 10k squared, negative 15 plus 4 is negative 11k, minus 6. Okay, so let's look at two more examples. Example 3 is 3s plus 2 times 2s squared minus 2s plus 1. So this one is not called FOIL because it's not two binomials, but it's the same concept. The 3s is going to be distributed to all three of these terms. I like to show the arrows on the top, and then when we distribute the 2, we're going to show the arrows on the bottom. So 3s times 2s squared. Well, 3 times 2 is 6, and s times s squared is s cubed. Okay, then 3s times negative 2s. 3 times negative 2 is negative 6, and s times s is s squared. 3s times positive 1 is positive 3s. After that, we're going to distribute the 2 to all three of these terms. 2 times 2s squared. Well, 2 times 2 is positive 4, and then s squared. 2 times negative 2s is negative 4s, and positive 2 times positive 1 is positive 2. Then from here, we are going to combine like terms, starting with the highest exponent first. So in this problem, our highest exponent is s cubed. So I'm going to combine all of my s cubes. Well, I only have 6s cubed, so I'm going to write that down first. Then I'm going to go and combine all of my s squared pieces. So I have negative 6x squared and positive 4s squared. Negative 6 plus 4 is negative 2s squared. Then I'm going to combine my s's. So I have positive 3s and negative 4s. 3 minus 4 is negative 1. Now here, we don't want to put a 1 in front of a variable. The variable is known that it has a 1. So we just write down minus s. You can put a 1, but it's not necessary. And then the last thing is always to combine the constants last. So I don't have anything else to combine that positive 2 with, so I just write down positive 2, and that's my answer. So there's one more example. In this last example, you are asked to solve this problem. Okay, so when you see this problem, we have two binomials on each side. So what you want to do is FOIL on both sides first and then solve for x. Remember, FOILing is just like distributive property twice. So I'm going to distribute my 3x to both of those first. 3x times 2x is 6x squared. 3x times negative 3 is negative 9x. Okay, then I'm going to distribute the 5 to both. 5 times 2x is positive 10x. 5 times negative 3 is negative 15. Okay, so we FOILed on that side, bring down the equal sign. Now I'm going to FOIL on this side of the equal sign. So, or distributive property twice, x times 6x is 6x squared, and x times positive 5 is positive 5x. Then I'm going to distribute negative 1. Negative 1 times 6x is negative 6x, and negative 1 times 5 is negative 5. Okay, so I'm going to combine like terms. Remember what I said, the two middle terms should be able to be combined. So I have negative 9x and positive 10x. So I have 6x squared, negative 9 plus 10 is 1. You do not have to put a 1 in front of the variable. It's known that it's 1. So 6x squared plus x minus 15 equals, on this side we have 6x squared. 5 minus 6 is negative 1, so I write down minus x minus 5. Okay, then we want to combine to solve, we want to get like terms together, so I'm going to move the 6x squared, this 6x squared, over to this side. The opposite of addition is subtraction. And I don't want to put this 6x squared with the x. It has to be like terms, okay? So it has to match up with the x squared. Well, 6x squared minus 6x squared is 0, so those cancel. And they also cancel over here. Then I'm left with a new equation, x minus 15 equals negative x minus 5. Okay, so I'm going to bring my x over here. The opposite of negative x is adding x. Those cancel. And x plus x is 2x. So now my new problem is 2x minus 15 equals negative 5. Okay, so then I want to move this 2 and the negative 15 to the other side. Remember, we're trying to combine like terms, so I want to move negative 15 with the negative 5. To get it to the other side, the opposite of subtraction is addition, so I'm going to add 15 to both sides. Negative 5 plus 15 is 10. So I'm left with 2x equals 10. Now I need to get this 2 to the other side. The opposite of multiplication is division. And 10 divided by 2 is 5. So x equals 5. And then if you would like, you can plug in 5 into both sides of the equation. Find what you get on this side, plug in 5 and find out what you get on that side. They should be equal. If they're not equal, there was a mistake somewhere. If they are equal, you did it correctly. So this was multiplying polynomials. I hope you all found this helpful. Thank you all for watching, and I'll see you all next time.